A lot of liquid coolers are made by the same couple of companies, and today what we're going to do is show you the internals of various closed-loop liquid coolers as they're available on the market. So these are mostly Corsair coolers. We also have an EVGA cooler, but there's one common thread between them, and that's Asetek. The difference is that Corsair somewhat recently has gone back to using the other supplier, CoolIT, for its H115i Platinum cooler. So the difference is we're going to take this apart today, see if CoolIT has any internal changes from what Asetek's doing, and they probably do, and then talk about the differences between really just the couple of actual cooler suppliers that exist on the market and how they relate to the manufacturing brands that you all know. Before that, this video is brought to you by EVGA's Z390 Dark motherboard. The Z390 Dark is a flagship motherboard for Intel's unlocked K-SKU CPUs with tuning done by overclock engineering team Kingpin and Tin to enable higher memory and CPU frequencies. The motherboard uses a unique rotated socket design to move EPS 12-volt cables to the right side, making cable management easier, and also sticks to 2 DIMM slots to improve memory overclocking stability and headroom. We previously analyzed the VRM in full and found it among the best in class for Z390 overclocking, and it also got rid of RGB LEDs. Learn more at the link in the description below. We've previously done teardown videos of these coolers, but let's just walk through it for all of our newer viewers. This is an EVGA CLC 120, and this was a product we didn't recommend buying. The CLC 280 or 240 were fine, but this just didn't make any sense. Either way though, the way they're assembled is all the same, and the difference is just radiator size and the fan, and ultimately the difference really between Corsair, EVGA, NZXT is mostly going to be fan choice and RGBs, LEDs, and the design of the identity of the cooler, but the product itself doesn't really change from product to product in terms of the pump. So this is what an Asetek pump looks like. There are different generations. There's Gen 4, there's Gen 5, there's Gen 4.5, and we have some like this old Corsair H110. This is what's left of a year's old teardown we did, but that's the impeller. It's the same impeller design for the Asetek Gen 4, Gen 4.5, and Gen 5 designs. And it just sockets in there, it's a magnet, and it's got 3 prongs and it spins. That's all there is to it. We'll cut to some footage of the Gen 6 pump design where the impeller is a much larger piece of metal that sits inside of the entire interior of the pump housing. So it's a bit higher quality, but the real differences between generations are pretty minor. And in terms of thermals, the Gen 6 cooler is actually worse than the Gen 5 pump from Asetek, and that's just because Gen 6 focused more on permeation. So the biggest issue with liquid coolers is with time, there is permeation. The rate of permeation is not as bad with Gen 6, but it's still there, and what happens is the liquid permeates into the tubes. And Asetek uses rubberized tubes. They're much more flexible. There's no interior housing. So on the Cooler Master tubes, there's actually an interior Teflon coating, and that would prevent this kind of bend I'm doing right now. If you did this on the Cooler Master ones, like what's used on the Fury X, then what would happen is you'd crack that Teflon lining inside, and the permeation would be really bad. So they're less flexible, but that Teflon liner does help a lot with permeation. It's just the downside is obviously there. This, there is going to be permeation. That's why most of them are rated for 5 years of use. And so the changes to Gen 6 for permeation. The internals of the average Asetek pump go like this. There's the cold plate, and it has a bunch of microfins in it. They are very dense. We have a video showing how liquid coolers are made where we have some footage, and we'll pop that in too, of the skiving machine that makes these cold plates. So it's copper contact to the CPU or the device. The microfins give you a lot more surface area. The water goes through those fins that way, and the only limitation is making sure there's not too much flow impedance, where if the fins are too close together, the liquid actually can't move through it, so that would be bad. So this is what you end up with. There's a set of channels in here too, and this gasket goes on top of it. So the gasket goes on top. You can see how it lines up right here. So this gasket just pops down on top of the cooler, and this might not be the exact one for this cooler, but they're all the same idea. And this still has the plate on it for this, the one we pulled this off of, but you can see the inner chamber design. It's got a piece of foam here. This is often for vibration, reducing some of that coil or the pump whine, so the pump vibration noise. There's the top of the pump housing, which has the outlet and inlet for the tubes, and the electromagnet as well that powers the pump itself. And then you'd socket everything in here, so that would be the cold plate goes in here. There's some corrosion, but you get the idea. So the cold plate goes in there, water goes in one, goes through the cold plate, comes out the other. Some assembly elements. This isn't on all of the Asetek coolers, but it's another foam damper that goes into this part, and that's just for vibration reduction once again. If I remember correctly, NZXT has one as well. We have teardown videos of those too. Then the pumps come in and out of the housing, and that's really about it. One of the other differences in Gen 5 and Gen 4 is how the pumps are mounted, going into the top versus coming off the side, though the manufacturer could change this. And then the PCB design too. So the PCB, this is EVGA's, but NZXT made its own PCB, something that Asetek really doesn't allow, but they did for Gen 5 with NZXT. And this has on it a thermocouple, which is right here. So that probe is coated in thermal paste, and it sits down into the liquid chamber so that you can get a liquid temperature reading. If the liquid temperature goes over 60 degrees Celsius, then you start having some serious, well, two problems. One of them is serious permeation issues. The other one is you start damaging the plastic inside of the pump. And so Asetek's maximum rated temperature is 60 degrees liquid temperature, not CPU temperature, much different in what those numbers mean. So 60C internally would mean your CPU is really roasting or you have high case ambient. So that's how those look. This is an older Asetek design, Corsair H110. You can see the coils for the motor itself, the PCB, and then the impeller down there. But the impeller for most of these designs up until Gen 6 was the same. Gen 4.5 was just a faster pump speed, useful for things like GPU cooling with the EVGA hybrid coolers or with Thermaltake's flow. So that is what they typically look like. That's an Asetek pump, more or less. That's really all there is to it, even the modern versions. We have here an H115i. This was previously disassembled. As you can tell, pieces of it aren't put back in right now, and it has some corrosion on the cold plate. But we hopefully have already shown some footage. We'll pop some more in, but the interior is a bit different. Otherwise, the disassembly process is about the same for all the others. And then today, we're taking apart the H115i Platinum. So this is the one we're taking apart today. And the bottom of it is secured with just Phillips heads, so that's nice. Hopefully they're not as tight as the Asetek ones. The Asetek ones are really hard to get out. We've historically had to drill at least one of the screws out because they get stuck, and that's because of how tight they're screwed in at the factory. And then I'm not quite sure what these things are right here. There's three of them, 1, 2, 3. It might just be to help align the plate onto the block, onto the chamber, but we'll see once we take it apart. So this one, we're going to take the cold plate off first. That'll drain it, and then we'll go from there. All right. Wow. Okay, well, much easier start than the Asetek ones, which isn't necessarily good or bad, but the Asetek ones, we'd already be straining right now to get these screws out. They're also typically Torx. So we'll speed through this process and then see what's underneath. So there's just a small spot where you could force it open with a wedge, and that was by design, so we popped that off. So this liquid is just propylene glycol. These mixtures in liquid coolers are distilled water and propylene glycol. Typically it's about 20% propylene glycol, but they'll go up to 40% depending on the storage and usage conditions. Industrial applications might use a higher percent. Distilled water is better for thermal capacity and transfer, but propylene glycol is used for reasons like better cold storage temperatures, things like that. It also has a biocide in it to kill any bacterial growth because water is a great place for that to grow. Let's empty out the rest of this cooler. So here's the cold plate that came out. And once again, we have a gasket on top. This is for directing the flow. Or actually, it's just on the inside of the cold plate. If we peel the gasket off, which is just rubber, you'll see the microfins. So here's the CoolIT microfins, and here's the Asetek one. A lot of these pump makers and the closed loop liquid cooler makers, just like anything else, they buy a lot of their stuff from elsewhere. So we don't know if CoolIT's making their own cold plate or if they're just buying it from someone who has a skiving machine, or a lot of them, but that's what it looks like. And same for every other material, like the rubber gasket is very likely made by a third party and then just designed by CoolIT or Asetek. So CoolIT's got a squared off block. The real question is just, is the contact area any different? Is the fin pitch or density any different? And the fins actually are different. So if we get a close-up of this, you'll see that the CoolIT design has it's trapezoidal. So the fins are coming up at an angle over here, flattening, and then coming back down. It's not that different from Asetek. It's just that Asetek's is flat on either side, but otherwise it is the same idea. We don't have any tools to measure the fin density, unfortunately, but we can see that the shape has changed a bit. The CoolIT ones are also, well, actually, they're really not that different. Asetek, keeping in mind, is a bit more square, but Asetek's 31 millimeters or so by roughly 26 millimeters, and CoolIT's about 30 millimeters by roughly 27 millimeters. The difference being that the last millimeter of CoolIT's is shorter. But otherwise, they're really not that different. The squared off change is quite different, and then the microfins themselves are about the same. There's also a difference up here. So at the top end right now, you can see how when it was manufactured, it's got this sweep coming down, as opposed to the Asetek design, where the flow is guided a bit differently with the chamfered edge all the way down to the bottom, that first fin, instead of the angle going out to the sides with the flow directed around the microfins and coming back in. All right, that's just the mounting mechanism. Dang. Aha, okay. All right, so there's the flow. Liquid comes in one of these, comes out the other, of course, and in doing so, this plate is situated here to guide it. So there is a, oh yeah, this is my broken screwdriver. I guess I can use it for this. So it looks like it comes in or out here, not sure which. It hits that, this looks like the impeller. Yeah, the impeller's in there. We can get a closer look at that when we disassemble the rest. So you can see I can actually rotate it a little bit. So it's hitting the impeller in there, and the liquid is flowing, it looks like, through this channel and through here, and then through all the microfins that would be sandwiched right against that. So the water is going to flow out of this or into, either way, direction I'm not positive on, but water goes through here and through the microfins beneath it, and that's your direct path. What we need to do is get the impeller out, though. And this is like a fill cap, I think, but I'm not sure how to get it off. Okay.
How is it just glued?
It's tape. Okay, really sticky tape holding that in. So really sticky tape holding in the top plate, which covers 2 more screws. All right, well, that's one huge screw. So that was going into the LED diffuser plate. And then this is clipped in. We've got foam just to pad for vibration, which is consistent with the Asetek designs. Under that, fancy white PCB for all the LEDs. Oh yeah, you can see the same thing. So right here, so you can see those 2 copper wires there. They're probably going down to the coils underneath, which means as soon as I remove this PCB, those wires are going to snap, but that's fine. We're not rebuilding this anyway. So now we're going to break some copper wire off. So before I snap it, there's what it looks like. So that's where the PCB connects to the coils, and we're gonna terminate that connection, sadly. You can see the wires are soldered into the PCB, but the PCB is not all that different from what you'd find in really any other product. So this pops up. There's the impeller. Okay. All right. So there's the impeller base, and you can see that there's the copper coils will be in there. Let's compare this. So Asetek design, that's the same piece right there. And then the impeller goes on the other side. And this one uses, it's got a gasket, as you would expect for being a liquid cooling product. And then the motor's in there. The impeller is quite a bit different. So here's the CoolIT impeller. And then here's the old Asetek impeller. And then we'll show once again briefly the Gen 6 impeller. But Gen 6 impeller is pretty similar to CoolIT's choice here, whereas Gen 4, Gen 5, very different. And this will impact rate of flow and the noise that you get out of the pump too. So then the rest, this is a fill port, not sure, trying to remove it went wrong, so whatever, it's fine. We're not rebuilding it anyway at this point. These little things, we didn't figure out what those do just yet. And then the tubes come into the housing. So it's really pretty simple design, but it's not too dissimilar from Asetek's. Somehow it theoretically doesn't interfere with the patent that Asetek has on putting a pump inside of a block. Deepcool bypasses this by having a multi-chamber approach. Other companies bypass it, like EVGA, by having the pump built into the radiator instead of into the CPU block, but it's worse for a lot of other reasons, like radiator size gets kind of ballooned. So anyway, this is what the CoolIT one looks like, and you can see just how the differences more or less boil down to the impeller choice and some of the flow choices, but overall it's the same basic idea. Some differences, and for example, where do you put the foam padding to damp the noise, and that's just going to vary product to product based on where each one has noise issues. So there's the differences between CoolIT and Asetek. We have some old footage we'll go find and put in here of the Antec 1250 that used Dynatron for their supplier. Apoltex, another popular supplier, they have been used by Silverstone in the past, for example. And Cooler Master makes their own. We've seen their factories and toured them. Deepcool mostly makes their own. They're all about the same. I mean, a lot of these companies will assemble it in-house. They might buy an impeller from over there, rubber gasket from there, tubing from another place, and then put it together and you have the product. But that's what they look like on the inside. If you've been curious, if you've felt disillusioned that all liquid coolers are the same, don't worry, you were pretty close to accurate, but there are some important differences. So what the companies actually do, like what Corsair does, what NZXT does, what EVGA does, they dictate the design within the parameters of what the generation of pump can do, or how much it can deviate from the base spec. So what they'll do is design a PCB like this one Corsair had in here. Whether or not they designed it, I'm not sure, but typically the manufacturer will design the PCB, go to the supplier and say, we want to use this PCB. And then that will integrate with whatever software they want to do. It'll integrate or control the RGB LEDs. That's a huge differentiating factor these days, which is why you see it a lot. The pump speed, to some extent, can be dictated by the manufacturer, the brand that puts their name on it. So if they want a faster pump, a slower pump, they can somewhat dictate that within the parameters or the specs of the base product. And then the fans are the absolute biggest difference. Beyond that, it's things like tube length, tube color, cabling, cable management, and how the product comes together. They can also, to some extent, dictate things like cold plate size. So Corsair, because Corsair was the initial and primary partner for the Asetek Gen 6 pump, Corsair did get to control a lot of the Gen 6 design as Asetek made it. And that was a unique advantage for Corsair. So Corsair chose a very slightly smaller cold plate for their Gen 6 coolers versus their Gen 5 coolers. And that's something that Corsair was to our knowledge dictating, not Asetek. And that's kind of where they deviate. Fin pitch, fin density to some extent can be dictated by the manufacturer as well. So there's a lot of things they can do, but it is ultimately made by other people, as everything is in this industry for the most part, until you get down to base supplier level. Even though these radiators, they're bought from often other companies, from suppliers of radiators, not from liquid cooling companies. So yeah, that's it. We have another video on how liquid coolers are made if you want to watch that, but we'll wrap this one here. Thank you for watching. If you want to pick up the mod mats I was working on, they are anti-static mod mats. They're a great build service for protecting the table you're working on, and also very water resistant, as we've learned regularly from these. Subscribe for more. You can go to store.gamersnexus.net to pick up one of the mats. I'll see you all next time.